product of the vectors, scalar product.
I didn't understand that multiplication of vectors with numbers.
Your voice is cracking.
So now can you hear me?
Uh, okay, we will wait for 2 more minutes for the other student, then we will start. Just revise your note. Revise your notes. Okay, so I'm starting. So scalar product or dot product. Scalar product or this is scalar product is also known as the dot product. So are you getting my voice properly?
Yes, sir.
Mm, your mic is not working, so you can use chat box. Okay, so dot product is very simple. This is one vector and this is another vector. This is one vector, this is a vector, this is b vector, and angle between the two vectors is theta. So dot product is written like this: a vector dot v vector, and when you open this dot product, you will write this like this: magnitude of a vector, magnitude of v vector, and cos theta. Okay, or magnitude of a vector, we can also write a, or magnitude of v vector, we can also write v. So simply you can write this ab cos theta, ab cos theta. So this thing, a will be the magnitude of a, v is the magnitude, and cos theta is some number. Okay, so you will get the scalar. So result of the dot product, you will get the scalar. Result will be scalar. For example, I am giving one example of the dot product. Work done. Work done. Work done is W, I will say. So work done is a dot product of force vector and displacement vector. Okay, F is the force and S is the displacement. In the chapter work power energy, I will discuss what is work. So dot product, work is a dot product of force and displacement. We can take one more example: power. This also we will discuss in work power and energy. P, power is the dot product of force and velocity. So V is the velocity. Is the velocity. So dot product is given by A dot B is equal to AB cos theta. A is the magnitude of A vector, B is the magnitude of B vector, cos theta, cos, and theta is the angle between the A vector and the V vector. So there are some properties of this dot product of the vector. So first property, this is commutative. Commutative means just a minute. You have written A vector dot B vector, then you can write is equal to B vector dot A vector. If you will change the order, the value of the dot product will remain same. First property. Why the result is scalar? Very simple. See. See. Suppose A vector is 2 I cap, okay, and V vector is 3 I cap, okay. So when you will do dot product of A vector dot B vector, okay. So what you will do, you will write 2 I cap dot 3 I cap, okay. This you will write now. So finally 2 into 3 is 6 and I cap is 1. So you will get this 6. Another way, suppose this is a F1 vector, like 6 Newton. This is F2 vector, 4 Newton. Angle between both the vectors 60 degree or 30 degree. So I am saying calculate the dot product of F1 and F2. So what you will write, F1 F2 cos theta. F1 is the magnitude, F1 is the magnitude of F1, that is 6. F2 magnitude of F2 vector, that is 4. And here you will write cos 30 degree. So this will become 6 4 the 24. Cos 30 is root 3 by 2. So you will get 12 root 3 Newton. So is this scalar or vector? Scalar, na? This whole term is scalar. This whole thing. Yeah. Now got it? Okay. Okay, good. So properties of scalar product. First is this dot product is commutative. If you will change the order, then the value of the dot product will not change. So A dot B is equal to B dot A. Second property, the dot product is very simple topic. So when vectors are parallel, dot product is maximum. So see why the dot product is maximum when the vectors are parallel. Two vectors are parallel means the angle between these two vectors is equal to 0 degree. Already told you. If you want to calculate A dot B, this is a dot product. So A dot B is given by AB cos theta. So what you will put here, AB cos 0. Okay, so this cos 0 is 1 and this 1 is the maximum value of cos. So maximum value of cos theta is equal to 1. We already know maximum value of cos is 1. So finally you will get the maximum value of the dot product, that is AB. If you will change the angle, suppose angle is 60 degree, angle is 60 degree, okay, theta is 60 degree, then you will get A dot B and the angle between A and B is 60 degree. So you will write AB cos 60. This will become AB cos 60 is 1 by 2. So you will get AB by 2 and here you are getting AB only. So this is the maximum value and this maximum value will be at 0 degree. Okay, different angles you will get. This is the second property. Now third property. A dot A. Simply A dot A. It's very easy. A dot A means A vector and A vector. What is the angle between A vector and A vector itself? 0 degree, na? 0 degree. Yeah. So I can write this A into A. This will become A square. And cos 0 is 1. Cos 0 is 1. Simple. See, if the vectors are perpendicular, dot product is 0. So this is very simple. This is one vector. This is another vector. The angle between the two vectors 90 degrees. So theta is equal to 90 degrees. So dot product of A dot B. So you will write here AB cos theta or AB cos theta. AB cos 90 you will put. Cos 90 is equal to 0. So this thing will become 0. This whole thing will become 0. This cos 90 is 0 means this cos 90 is 0. This 0 is multiplied by anything will become 0. So this is equal to 0. Simple. For example. Uh, okay. Now take this example. This is x-axis and along x-axis the unit vector is I cap. Along y-axis the unit vector is j cap. Along z-axis unit vector is k cap. Okay. So if you will calculate this I vector dot j vector. If you will calculate I dot j, dot product of I vector and j vector. What is the formula of dot product? First vector, magnitude of second vector, magnitude of first vector, magnitude of second vector, and angle between them, cos of angle between them. What is the angle between I vector and j vector? This is I vector and this is j vector, 90 degree. So we will write here cos 90, and cos 90 is 0, so this will become 0. If you want to calculate the dot product of this vector with this vector, I vector with k vector, I dot k. So you will open this I, k and cos 90, because angle between this I vector and k vector will be 90 degree, cos 90 is equal to 0. So when you will do the dot product of the unit vector in different directions, then you will get 0. Here is one more case. This is x-axis. Along this vector is I cap. This is y-axis. Along this j cap. Z-axis. Along this the unit vector is k cap. Now if you are just calculating the dot product of I dot I, so when you will open this, magnitude of one vector, that is I cap, magnitude of another vector is again I cap, and cos theta. What is the angle between the vector I cap and again I cap? I cap and I cap 0 degree. So cos 0 is 1. So you will get this, and I cap is the unit vector. So magnitude of this I cap will be 1, and this will be 1, and this will be 1. So this will become 1. You will calculate j cap dot j cap. So j cap and cos 0. This is 1. Again this is 1. This is 1. This become 1. So distributive property means you can write, if the vector is written in this form, you can write this A dot B plus A dot C. Simply this A is distributed to V vector and also to C vector. Okay, now see dot product in Cartesian form. Cartesian form, I have told you, if you are writing a vector in terms of the unit vectors, that form is known as the Cartesian form. So this A vector is written in the Cartesian form and V vector now is in the Cartesian form, and we want to find A dot B. So what A dot B means, A dot B is given by simply A1 B1, because this dot product of I vector and I vector will be 1, already discussed. This will be 1. This will be 1. 1. Okay. So here is A1 into B1, A2 into B2 plus A2 into B2. Here A3 into B3. Very simple. So taking one example here. For example, A vector is given as I cap plus 2j cap minus k cap. Okay. And B vector is given as I cap plus 3j cap plus 4k cap. We want to find A vector dot V vector. Can we find it? Here is 1, here is 1, so this will become 1. Okay, and plus sign, here is 3, here is 2, this will become 6, plus here is 4, here is minus 1, so this will become minus 4. So final answer will be 3. So dot product of vector or scalar product is very simple. So just note down this. Okay. Okay. No need to write this, because if you want to write, then you can write, otherwise there is no need. Okay. You can only write in the chat box W. Okay. It will save our time. Only W you can write when complete. So now we will use the properties of the scalar product to solve some questions. Very easy questions I will take. Okay. This dot product is very simple. But in cross product, we will have one cross product also. In cross product is also easy, but in direction, there is some problem for the student. And please remember these unit vectors along x-axis, along y-axis, along z-axis, along negative z-axis. Unit vectors are very important. For the direction, we use the unit vectors. Suppose if I want to show the direction along the x-axis, then I will use the I cap. And this property is important. If two vectors are perpendicular, then dot product is 0. Okay. Okay, done. Dot product in Cartesian form. Just write this. And remember this also. I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1. These are the unit vectors. Completed this? Okay. So I am giving you one question. Okay. On this, then just tell me the answer only. Okay. So suppose your A vector is given as I cap, your V vector is J cap plus K cap. You have to find A dot B. You have to find A dot B. Just tell the answer only. No. See this. A dot B you have to find now. So how we have find it here A dot B? See, I have just multiplied the coefficient of I cap, that is A1, to the coefficient of I cap, that is B1 of another vector. Okay, A1 and B1. See here I have written it. So this here is I, here is the coefficient of I is 1, so I have multiplied 1 with 1, it is 1. Here is 2 with 3, 6, minus 1 with 4, it is minus 4. So here now what you have to do, here coefficient of I cap is 1, coefficient of I cap here, coefficient of I cap here 0 now. Just a minute. See now. So A vector can be written as 1 I cap plus 0 j cap plus 0 k cap. B vector can be written as 0 I cap plus 1 of j cap plus 1 of k cap. We can write now. So now find the A dot B. Find A dot B. So when you will find, you will multiply this 1 with 0. So this will become 0. Then plus sign. Then you will multiply this 0 with 1. Again here will be 0. Here will be plus sign. Then here 0 with 1. Here will be again 0. The answer will be 0. Okay. So just giving one more question. A vector is equal to I cap plus j cap. V vector is equal to 3 I cap minus k cap. Just find A dot B. Take your time. 2 minutes you can take and just try this. Because again and again there will be a requirement of the dot product. So you should understand the dot product of how to calculate the dot product of two vectors. This answer you have told me for the last question is a vector, not a scalar. Answer will be the scalar always for the dot product. Scalar means some value will be there. Okay, I am solving now. See here. 3. Okay, checking. Here is I cap. Coefficient of I cap is 1. Here is coefficient of I cap is 3. So 1 into 3. Here coefficient of j cap is 1. Here the coefficient of j cap is 0. Here coefficient of k cap is 0. Here coefficient of k cap is minus 1. 0 minus 1 is 0. So your answer is right. Your answer is right. Okay. Just if you want to note it down, then you can note it. This part and this part. Then we will move to the next question. So with the help of dot product, we can find the angle between the two vectors. With the help of dot product, we can find the angle between two vectors. Okay. Now, this question. First, we will solve this question. This is very easy question. This vector is given. P vector is given this and Q vector is given this. Here, this P vector is perpendicular to Q vector. P vector and P vector and Q vectors are perpendicular. So, if P vector and Q vectors are perpendicular means if two vectors are perpendicular, then their dot product is 0. So you can write P dot Q is equal to 0. P dot Q is equal to 0. Then find P dot Q. P dot Q we can find, here is 1, here is 1. So it will become 1 plus. Here is 2, here is x. So this will become 2x. Here is minus 4. Here is plus 3. This will become minus 12. So x will become 11 by 2. Simple. Okay. This question. Okay. So in this question, they are saying calculate the angle between the A vector and B vector. Okay. Calculate the angle between the A vector and the B vector. So A vector is given this and B vector is given this. So how we will calculate the angle between the two vectors? Okay. Angle between the two vectors. Now see. See. We know the dot product of the two vectors A dot B is given by magnitude of A, magnitude of B, and cos of theta. What is theta? Theta is the angle between the two vectors. So we can find this cos theta from here. A dot B divided by AB. Okay. Now what is A and what is B? A is the magnitude of the vector, and I have told you how to find the magnitude of the vector A. See this vector A. Here is 1 square. Here is 1 square again. Here is minus 2 square. So this will become root 6. Magnitude of vector B, 1 square plus minus 1 square plus 4 square. This will become 18. Okay. Now cos theta, see, cos theta is A dot B. Cos theta is A dot B. So can we find A dot B? Okay. A dot B we can find. I plus J minus 2K dot I minus J plus 4K, and A B you have root 6, root 18. A and B. Okay. Now we can find the dot product. So this is I cap, this is I cap. This will become 1 plus. This is J cap and this is minus J cap. So this will become minus 1 plus. This is minus 2 and this is plus 4. So this will become minus 8. And here is root 6 and root 18. So here we will have this is minus 9 and this 1 and 1 will be cancelled out. This will become minus 8 divided by 108. Okay. So your theta is equal to cos inverse minus 8 divided by 108. Simple. 108. Okay, suppose you have tan theta is equal to 1. So your theta will become tan inverse. Here is inverse 10 to the power minus 1 and 1. So like this, theta is cos inverse minus 8 by 108. Got it? Got this? If you have any doubt in this, then you can ask me. This is a simple calculation. Just I have put what is A dot B divided by AB. AB is the magnitude. Okay, just first note down this. Okay. Okay. Just wrote this. Okay, fine. So we will solve this question. Before solving this question, uh, you should know what is the position vector and what is the displacement vector. What is the position vector and what is the displacement? First, I will explain. Then we are able to solve this question. So position and displacement vector. So what is the meaning of position? Location. Okay. Position is location and displacement the shorter distance. Okay. So position and the displacement vector. For this, I am taking this as x-axis, this as y-axis. And suppose here is one point. Here is one point. This point is located here. Means the position of this point is this with respect to this origin. This is O point is the reference point or the origin, you can say. So what I am doing, and see the coordinate of this point. Suppose this point is the P point, and the coordinate of this point is x comma y. X comma y. So for the position vector, this is the vector we have. This is the position we have. Now we will make the vector of this. So you will draw a line like this from the origin to this point P. Okay, from the origin to this point P, and this is the position vector of point P, and this position vector is represented by R vector. R vector is the position vector of point P. Okay, so what I am doing now, just taking the help of geometry. So see, this is the R vector. This is the R vector, and this distance will be this distance. What will be this distance, Joylin? And Joylin, what is your name? Is okay, Joylin. Fine. Joylin, so tell me, what is this distance? this distance. This point is x comma y. Suppose this point is M, suppose this point is N. So I am asking you MP, and this angle is 90 degrees. Means you have drawn a perpendicular from this point to the x-axis. So see, this distance will be y, and this distance will be x. This distance will be x, this distance will be y. Because this is the x coordinate, this is the y coordinate. So this r vector can be written as x I cap plus y of j cap. Okay, and this r vector will be the position vector of point P, of point P. So how I have written this? See, this is a parallelogram, this is a parallelogram, and this is the diagonal of the parallelogram, this is the diagonal of the parallelogram, and this distance will be y, and this distance will also be y. Okay, this and this distance will be same, and this distance and this distance will be same. So this OM length is along the x direction. So I can write this as y into I cap. Y into I cap. This is not y into I cap. This is x into I cap. I can write this distance is x. So this distance will be x. For this I can write y into j cap because this length is along the y axis. Okay, this is why I have made this y into the vector. So for vector, y is the magnitude and j cap is the direction. J cap representing the direction. Okay, so we have ON vector as y into j cap and OM vector is equal to x into I cap. So when you will write the position vector from the parallelogram law, you can write the position vector. Okay, you can write the position vector R vector as OM vector plus ON vector. So OM vector is x I cap and ON vector is y into j cap. So this is your position vector. For example, here's a point having the coordinate 2, 3. Okay, 2, 3. And we have to write the position vector of Q. We have to write the position vector Q for position vector for Q. So how you will write this R vector? How you will write? You will write x I cap plus y of j cap. What is x? This is x. This is y. You will write 2 of I cap plus 3 of j cap. Simple. And if you have the point like this, suppose 3 coordinates are given. This is a point Q, and for this point Q, 2, 3, 4 are the coordinates. This is x coordinate, this is y coordinate, and this is z coordinate. Okay. So position vector will be for the point Q will be 2 of I cap plus 3 of j cap plus 4 of k cap. Simple. 4 of k cap. This is the position vector for point Q. for Q. Now displacement vector. Displacement vector. Here is one point and here is another point, and you are moving from this point. Suppose this point is the P and this point is Q, and you are moving from P to Q. So first define the position vector for this point P. This is y-axis, this is x-axis. Okay, what will be the position vector? Suppose this is the position vector of point P, this vector. And this is the position vector for point Q. Position vector for point Q. Suppose this have a point, this have a coordinate x1, y1, and this point have a coordinate x2 comma y2, and take one more coordinate, means z coordinate also take x1, y1, z1, x2, y2, z2. Now you want to find the position vector or displacement vector from P to Q. So the displacement vector from P to Q will be this vector. This will be the position vector, displacement vector, or this will be represented by Rpq. Rpq vector. Rpq vector. So Rpq vector will be R of Q vector minus R of P vector. What is R of Q vector? Position vector of Q. R of Q vector means position vector of Q. R of P means position vector of P. Okay. So how you will write the position vector of Q? Position of vector of Q, you will write x1 I cap plus y1 j cap plus z1 k cap, and position vector of P you will write, see the coordinate of P, x2 y2 z2. So you will write here x2 I cap plus y2 j cap plus z2 k cap. Now we can find Rpq vector. Rpq vector will be Rq is this. You have to just subtract this from this. So this will become x2 minus x1. This is Q, na? Okay, this is P vector actually. Rp vector, and this is Rq vector. Okay, because the coordinate of Q is x2, y2, z2, and coordinate of P is x1, y1, z1. Okay, Rp and this is Rq. So this will become Rq minus Rp, Rq minus Rp, x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. So this will be your final displacement vector. Okay, this is your displacement vector. From P to Q. If you want to find the displacement vector from Q to P, then you will write x1 minus x2, y1 minus y2, z1 minus z2. Accordingly, you will do. If you are going from Q to P, then you will write the displacement vector of QP x1 minus x2 I cap, y1 minus y2 j cap, z1 minus z2 k cap. If you want to find displacement vector from P to Q, then you will write x2 minus x1 means final minus initial you have to write. Just copy this. So first is the position vector. And from here, displacement vector. Okay, write down. When I will take the question, then you will understand uh, clearly that how we will calculate the position vector and the displacement vector, and from the position vectors how we will calculate the displacement vector. Rate of change, if the position is changing, if someone's position is changing means there will be some displacement. Okay, so this is your x-axis, this is your y-axis, x and y. Horizontal line is x-axis, vertical line is y-axis. Okay, this is Rp here. This is P and this is Q. This is Rpq. Rpq vector. Done? Okay. Completed. Okay. So you should have idea what is the how to write the position and the displacement vector in this question. First, write down this question. Okay. Just try this question at your home. Okay, and you can left this part number third. I will discuss this. Third part I will discuss, but first part and second part at least you can try. I will discuss this question in the next class, but at least I want that you should try the first part and the second part. Okay, so just write this. Try this also. Because in the first part you have to calculate the position vector. In the second part you have to calculate the displacement vector. Harsh, just wait for 2 minutes.